Hi guys, this is Unit 2, Lesson 7, Properties and Strategies. So we're going to be learning about a few properties of mathematics, properties of addition to be specific, and how we can use our knowledge of those properties to help us solve addition problems using mental math. So first off, we'll just begin taking a look at the properties. We have the commutative property of addition. We have the associative property of addition, and we have the distributive property of multiplication over addition. So before we get started with any sample problems, let's take a look at what do the specific properties mean. What do they tell us? So first off, let's look at the commutative property. Here we have an example, a plus b equals b plus a. So some number a plus some number b equals some number b plus some number a. So that means that the order does not affect the sum when adding numbers. So let's just kind of look at this one as an example. 23 plus 14 plus 7. So what the commutative property of addition tells me is I can rewrite those numbers in any order and still come up with the same sum. So 14 plus 7 plus 23, I'll come up with the same sum as if I added in this order 23 plus 14 plus 7. Okay, now let's look at the associative property of addition. So in our sample here we have inside parentheses, which what that means is that you would perform the operation inside the parentheses first. So we have a plus b plus c equals a plus b plus c. So on this side, you would add b and c together, and then you would add a. What the associative property of addition is telling us is that you can group numbers together when adding in any order, and it will not change our sum. So let's just work out an example here to get a better idea of what that means. 23 plus 14 plus 7. If I look at this group of numbers, I see that 7 and 23 can be added together to give me 30. And I can do that using mental math. So I'm just going to go ahead and regroup them. I'm going to say 23 plus 7, and then plus my third number, 14. So if we look at it this way, regrouping it, 23 plus 7 gives me 30, plus 14 gives me an answer of 44. And I'm able to do that mentally just by regrouping those numbers to make that addition a little bit easier. So we'll work out a few sample problems here to give us a little better idea of how we can use those properties to come up with strategies in order to solve addition with whole numbers and digits or large whole numbers. So number one here says use what you know about the commutative property to solve for n. So 26,184 plus 1,546 equals 1,546 plus n, some number. Remember, the commutative property says that the order that numbers are added in does not change the sum. So just because the 1,546 comes first here, it's not going to change the sum. So if we come back, look on this side, we have 1,546, and then our other number being added together is 26,184. So that would be our missing number there, our variable for n. Let's check out number 2 here. 17 and 39 hundredths plus 12 and 58 hundredths equals 12 and 58 hundredths plus n. So our variable here would be the other number on this side of the equation, which is 17 and 39 hundredths. Notice that the order is changed, but they still are equal to each other. So our variable is 17 and 39 hundredths. Okay, let's take a look now at numbers 3 through 5 we'll work out the first two together, and then I'll have you guys do number 5 on your own. It says regroup the numbers using the associative property, then add. Remember, the associative property says that numbers can be grouped in any order, and it will not affect the sum when you're using addition. So if we look at this one, we have 7/10 plus 3/4 inside parentheses, which that parentheses means you would have to perform this operation first. But if I look at my denominators, I have a tenth, and then I have 4s in my denominators here. So I already have common denominators, so I'm just going to go ahead and regroup those numbers. Right, 7/10 plus, inside my parentheses, 3/4 and 1/4. Fix my 3 there a little bit. Okay, so now when I take a look at these two, I can add these mentally. 3 plus 1 would give me 4/4 or 1 whole. So I have 1 whole plus 7/10 for my sum. Again, just by regrouping those, I was able to add those mentally. So this is a good strategy to use. Number 4, we have 1 2/100 plus 98/100 plus 4 87/100 inside parentheses. So the parentheses would tell us that we'd need to add these two numbers first. But if I look over here in 1 2/100, I have 2/100 for a decimal, and I have 98/100. I know I can add those together to come up with 1 whole. So I'm going to go ahead and rewrite it like that. Put my parentheses around 1 2/100 and 98/100. So then I'm left with 4 87/100. So 2/100 and 98/100 gives me 1. Here's 1 more, so that's going to give me 2. Plus 4 87/100, I can do that mentally, would be 6 87/100. I'm just going to rewrite 4 87/100. 2 plus 4 87/100. 6 87/100. Okay, guys, I'm going to pause the video. I want to have you guys try number 5 on your own. I'll see you back here in just a minute. Okay, welcome back, guys. Let's take a look at number 5 and we'll see how you did on it. So I've rewritten it and taken my parentheses out, and I'm going to replace those around 2 5/8 and 3/8. Oops, I actually made a little mistake here. I wrote 3/8 twice. I have to go back and fix that because my other number being added was 2/3. Okay, now we're looking good. So I put my parentheses around 2 5/8 plus 3/8 because we have common denominator in our 8s here. So 5/8 plus 3/8 gives me 1, and we have 2 whole, so that's 3, plus another 2/3, giving me a sum of 3 2/3. Okay, guys, number 6 asks us to use the distributive property to rewrite the problem so it has only 2 factors. So let's take a look at the distributive property and what that is here. Okay, the distributive property states that when you multiply a number A by a group of numbers that are already added together, remember, because our parentheses says we do this first, so that says these two are already added together, you get the same answer as when you do each multiplication separately, which is what it shows on this side. A times B plus A times C. Okay, so if we take a look at an example problem here, we can get a little better idea of what that means. So A in our example here would be 6. So 6 times 2 plus 3 in parentheses, meaning we would add 2 and 3 together first to give us 5 times 6 is the same as if we multiply both 2 and 3 times 6 separately. So 6 times 2 is 12, plus 6 times 3 is 18. So 6 times 5, we get 30. And 12 plus 18, we also get 30. So this is called the distributive property because in this example, A, or 6, when multiplied by these two numbers that are already added together, you can also distribute it between both B and C, or in our example, 2 and 3, and multiply those numbers separately to get the same total. So in our problem number 6 here, if we look at the way it's written here, we have 25 times 9 inside parentheses plus 75 times 9 in parentheses. So that 9 has been distributed out to multiply both numbers separately. But if we look at the numbers that are being multiplied by 9, we have 25 and 75. And I can easily add those together mentally to come up with 100. So it's actually asking us to rewrite that. So we'll go out here and rewrite that. So we have 9 times, in our closed parentheses, 25 plus 75, which is where I got 100 from. So if you see, I just took both the numbers that are being multiplied by 9 separately and put them inside parentheses to add them together first. So that would give us 100. Over here we have 9 times 100. Can be done mentally, giving us a product, an answer of 900. Okay, come down here and look at a couple more examples. So this says for 7 and 8, group the numbers to make the addition easier, then add. So based on what we know from the associative and commutative properties, we can change the order, we can group these as we need to help us come up with an easier addition problem. So on number 7, when I look at this, 20,000 plus 70,000 plus 30,000 plus 68,000 plus 80,000, I can look at these and see that I can pair 20,000 and 80,000 together to make that much simpler. So if I have 20,000 and 80,000 giving me a total or sum of 100,000, so I'm going to go ahead and work those out. And I look here, 70 and 30,000, that gives me another 100,000. And then I just have to look and see what I have left after grouping those together, which is 68,000. So, and I'm writing this vertically, but I really don't even need to do that because by regrouping those to make the addition much easier on me, I can do all this mentally. 20,000 and 80,000 gives me 100,000. 70,000 and 30,000 gives me another 100,000, which is 200,000, plus 68,000, giving me a sum of 268,000. Okay, number 8. I take a look at this one. I have some decimal numbers that I can group together to do mental math and help me to solve this much easier. So if I look at these two, I can pair or group 10 and 7500s and 10 and 2500s together to give me 21. And I can also look and pair 10 and 4/10, 10 and 6/10 together to give me another 21. And then we just have 10 and 57 hundredths more to be added to that. So 21 plus 21 gives us 42, plus 10 and 57 hundredths more would just be 52 and 57 hundredths. So by grouping those together, it makes it much easier to solve that using mental math. Let's take a look at number 9 here. On Monday, Mr. Borden ran 4 6/10 miles in the morning and 78 hundredths miles that afternoon. On Tuesday, he ran 3 4/10 miles. How much did he run on Monday and Tuesday all together? Write an equation and solve. So if we look at these two distances that he ran, we see that we have 4/10 here and 6/10 here. We'll go ahead and group those together because we can add those mentally. So 4 6/10 plus 3 4/10 plus our third distance, 78 hundredths. So there we have our equation, and by grouping these two together, it allows us to add this mentally. 4 6/10 plus 3 4/10 gives us 8 miles plus 78 hundredths of a mile would be a total of 8 78 hundredths miles. Remember, we want to include our units here. Okay, guys, that does it for today's video. We will see you here in class.